Ready, Ben?
Yeah.
The title here is Dimensional Analysis or Unit Conversion. This is actually a really handy tool to have in your tool belt. Yesterday during Flex, I can't remember who it was. It might have been someone from this class. I was helping someone with a chemistry question. I'm okay at chemistry, but I figured it out by looking at the units. The chemistry question involved volume, and it had a length, and it had a width, and it wanted you to find a height, and then there was a density, which was in grams per cubic meter, and there was a mass. And I said, oh, well, density is grams, that's mass, per cubic meter. Density is mass over volume, so I can figure out how that equation works, and I can get the volume by itself, and once I get the volume by itself, I can figure out everything else. It's a really clever tool to have in your back pocket. It's a bit tricky. Those that are in chemistry, Mr. Perugia also teaches this. This also dramatically cuts down on your memorization, but you're going to want your green sheet out. We're going to start off very simply using metric prefixes. If you're converting metric prefixes, say going from 12 megagrams to grams, or going from 13.6 milliamps to amps, I call these one-step questions. Two-step questions are where you're going from one metric prefix to another metric prefix. Because what you're actually going to do is go from one metric prefix to nothing, and then from nothing to another metric prefix. And I'll show you how that's going to work in a second. For the one-steppers like this, it's a fairly straightforward substitution. On your green sheet, mega, capital M, is 10 to the what? 10 to the 6th? All you're going to do is you're going to replace that with a 10 to the 6th. That's a 10 with a 6 as an exponent there. And multiply. So on your calculator, you're going to go 12 times 10 to the 6th. And hit enter. You might get an answer in scientific notation. I don't quite. I get a 1, a 2, and then 6 zeros. I think it's going to be less work to write that answer in scientific notation, and so I'm going to choose, Fritz, to convert this to scientific notation. I'm going to write my answer as 1.2 times 10 to the 6th? To the 7th, because it's 7 places. If you wrote a 1, a 2, and followed with that with 6 zeros, I'd give you full marks because this question didn't specify whether or not I needed to write it in scientific notation or not. So scientific notation, Jack, when it's convenient. 13.6 milliamps. What can I replace milli with? So on my calculator, I go 13.6 times 10 to the negative 3. Now, this may look like scientific notation to you. We're not using our scientific notation button here. I know, Kira, it's also a 10. That's just a coincidence. It's because our metric system is based on base 10 and our number system is based on base 10. So don't go 13.6 e negative 3. You might usually get the same answer, but I can think of a few obscure things where weird stuff will happen. So this is not scientific notation. Do you get 0.0136? I could write that in scientific notation, Oscar, 1.36 times 10 to negative 1, but I think that would be more work and less clear. I think I'm going to write 0.136 amps. Yeah. No, you're going to use your exponent button, but not your scientific notation button. That's a very different button. Okay, look up. On my calculator, that's my scientific notation button. That's my to the power of exponent button. They're totally different buttons. I'll come there. Questions. Two-step questions. Can you see why I call it a two-step question? We're going from one metric prefix, kilo, to another metric prefix, strange funky thing. This is where I'm going to give you the conversion factor chain method. This works for anything. It's not always the quickest method, but it'll always work. You may have shortcuts, and if you have shortcuts for this, and you can always get the right answer, great. I want to try and give you something that's fairly mechanical. And so one of the things you're going to hear me say fairly often is I'm big whenever I'm doing a question. If I can write something down without thinking about it, I feel much better. My success rate goes up, the mental juices start to flow. So whenever I'm doing a unit conversion, the first thing I always do is write down what they give me. What's the first thing I always do? I write down what they give me. So what did they give me? And you're all going to do this with me. 13.6 kilograms. Abby, have we written something down? Do we feel better? Are we more relaxed? Are we more likely to succeed? Yeah. I can't call it a no-brainer. You have to have some skill, but there. Now, here's my strategy. Abby, I'm going to get rid of kilo. That's one step. And then I'm going to bring in, what is that funky symbol right there? What do we call that one? Yeah, what's it pronounced? It's not called mu grams. Micro. Okay? I'm going to get rid of kilo, one step. Bring in micro, second step. How am I going to get rid of kilo? I'm going to use the idea that things on the top and bottoms of fractions, if they're identical, will cancel. This is a fraction. No, it's not. Yes, it is. No, it's not. Yes, it is. What's anything always over? Okay, I'm not going to write that. Can you just imagine that there? But it is important to imagine that there so that you know that this is on the top. Okay. Everybody write times and draw a fraction bar. I want kilograms to cancel. So I'm going to put kilograms on the bottom of this fraction. Why? Because it was on the top of this fraction. On the top, I'm going to put just plain old grams, the base unit that it came from, except here I'm going to put the conversion factor. Kilo is 10 to the what? It's on your sheet. 10 to the 3. This is one way to write kilograms with numbers. This is a way to write kilograms with letters. The letters will cancel. And if I stopped right here, we'd be in grams. Now, why do I do this? Where is this 10 to the 3? On the top or on the bottom? Which means I'm going to multiply. If it was on the bottom, what would that mean I would do? This answers the big question Kira kids always ask me. Do I multiply or do I divide? The chain method tells you. It's on the top, multiply. On the bottom, divide. How do I know whether it ends up on the top or on the bottom? The canceling of the units will tell you. Do another times. Because Haley, I don't want to stop with grams. I want to stop with micrograms. So I need this G to cancel. Where is this G right now? On the? So where will I put it in the next fraction? On the? And I'll introduce micrograms right there. Except, this is not written correctly. I have to have a conversion factor, and the conversion factor always goes where the metric prefix, Matt, isn't. So it's never going to go there. On your green sheet, Matt, mu is 10 to the what? I think -6? Double check me. Micros? We're on the back page, right? You figured that out? Back page in the chart? Yeah. Micro, I think, 10 to the -6? Yeah. By the way, Matt, this 10 to the -6 on the top or on the bottom? This 10 to the -6 on the top or on the bottom? Which means if a number is on the bottom, I'm going to divide. On my calculator, I'm going to go, right now, all of you, 13.6 times 10 to the 3 divided by 10 to the -6. And this answers all of the questions of, do I times or do I divide? 13.6 times the top divided by whatever's on the bottom. And I get, now my calculator gives me this answer in scientific notation. This is right on the tipping point. Some of your calculators, especially if they're newer, they might actually display that in standard form. You would see a 1, a 3, a 6, and I think 8 zeros after that. Did anybody actually say, did their calculator show them a 1, a 3, a 6, and 8 zeros? Everybody got an answer? Then you typed it wrong. Don't clear anything. Don't clear anything. Okay? How many of you had an answer show up in scientific notation? Okay? Who has the TI calculators? We will have to translate. We're not going to write 1.36 E10. We have to remember that that little capital E is replaced with times 10 to the. So all of us can write 1.36 times 10 to the 10th. Don't clear your calculators. I'll come look in a second. I haven't forgotten. Other things to notice. Look up. You see grams cancels. What are the only units left behind on the top sitting all by themselves? This is micrograms. Pause for 1 second. Let's try the next one together. What's the first thing I'm going to do for number 4? What was that? Write down what they gave me. They wanted me to go from nanoliters to megaliters. Okay. 2,000 nano. By the way, little advice in math and in physics, if you're doing a lowercase l, never do a lowercase l like that, because what does that also look like? Yeah, so you'll notice I always write my lowercase l's like that. I will almost always, that's a 7, that's a 1, because from the back of the room it can be tough to tell. That's a 2, that's a Z. Because my writing is atrocious and messy, but you'll notice some of those. I will try and be as clear as I can fairly often. All right. We're going to multiply by a conversion factor. The first thing we're going to do is get rid of nano. Where is nano in the original number? On the top? Where's it going to be in the second fraction then? On the? So I'm going to put nanoliters here. Here I'm just going to put plain old liters, except next to plain old liters, next to the base unit, this is where the metric prefix is going to go. Don't memorize, oh, the metric prefix always goes on the top or always goes on the bottom. It always goes next to the thing that doesn't have a metric prefix. Right there. Nano is 10 to the negative something. Yeah. 9? Yeah. 9. Sicher. If we stopped here, this would be liters. Because can you see the nanos would cancel and I just have an L left. Do we want to stop with L? No. Times. Now I want the L to cancel and I want to end up with megaliters. Mega is 10 to the something. 6? Positive 6? Where is that going to go? On the top? No. It always goes in front of where you don't have a prefix. So it's going to go there. I guess that means I'm going to multiply the 10 to the negative 9 and then divide the 10 to the 6th. But I'll also do the 2,000. So on your calculator, follow along with me. You're going to go 2,000, Fritz. You're going to hit times. You're going to type 10. You're going to hit your exponent button, which is that little power to the power of negative 9, and then divided by 10 to the 6th. Again, Matt, this tells you whether you divide or multiply. It's a bit of a tricky concept to work your brain around, but when you wrap your brain around it, this bails you out of a whole bunch. And I get, I get 2 and then a little e, and I get 2 times 10 to negative 12. Is that what you got as well? Yeah. Okay. And probably none of your calculators went 0.000000000002. I'm suspecting all of your calculators went scientific notation. By the way, for conversions, we typically ignore sig figs. We assume that the conversion factors are exact to an infinite number of sig figs. So I'm just going to kind of go with what I got. Kira, did that work okay? Okay. One more. 342.5 kilometers, convert that to millimeters. What am I going to do first? What's the first thing I'm going to do? Oh, sure. 342.5 kilometers. Oh, what do I want to cancel? Okay, put it on the bottom so it'll cancel. What's going to go here? Just plain old. And what's the conversion factor that's going to go here? What's kilo? 1,000 or 10 to the 3rd. I'm lazy enough, Fritz, that I'll probably go like that because it's less writing. Now, if I stopped there, I'd be in meters. Now I want meters to cancel. I think I've done this rant before. I'll do it a few times again. Millimeters, we've run out of letters in the English language. If you see an M in front of another letter, that's milli, if it's a lowercase m. If you see an M after another letter, that's meters. You're going to find later on in physics, capital W means work, capital W means watts, capital W means west. Capital N means newtons, capital N means north. We'll have little tricks so that we can figure out in the context what it means, but we really need an English language with about 100 letters, but that would complicate other issues. Sometimes we'll pull out the Greek like we did for micro, if we're just stuck with something. So I want millimeters on the top, which means the metric prefix is going to go down on the bottom here, the metric number, sorry, not the prefix, the number. Milli is 10 to the -3. 342.5 kilometers is how many millimeters? It's probably going to be a fairly big answer. Fritz, did you get the right answer on that last one, by the way?
Yeah.
Okay. And now you're going to follow my instructions carefully and not make me walk back there?
Yeah.
Good, because I know where you live. I got a 3, 4, 2, 5, and 5 zeros. Yes? And that's often, if we're trying to compare answers, instead of trying to say, that's 342 million, you know what? Read me the non-zero digits and then how many zeros, and then we can all compare and know exactly that we got the same thing. So, yeah, 3, 4, 2, 5, 5 zeros, yes? Yeah. Do I want to write that in scientific notation? Or I think it's going to be shorter to write it in scientific notation. I'm going to choose to write that in scientific notation. Ben, if you wanted to write 3, 4, 2, 5 and 5 zeros, go ahead. But I'm going to go 3.425 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. I know, but I count so that kids can follow along. I can do all of these in my head. For the rest of the year, Vanessa, units matter. I will take a half mark off on a test or a quiz if you don't put the correct units next to your final answer. Which means, what would be a good habit to develop before you hand in your tests? Check for units, please. Okay? Units matter. Put your pencils down. So the good news is all of you are too smart to work for Verizon. Now, we had one student who said, I like to memorize useless, and that's great. But what I would like to try and do is see if I can use stuff that I've already memorized rather than having to memorize new things. So, part C, multi-step conversions using conversion factors. How many seconds are in 1 week? I'm going to ask, does anyone know? Because if you've memorized it, then you can write down the answer, and I'm fine with that. Does anybody know?
1,000.
Okay. Does anybody know? I didn't say guess. I said no. So, let's see if we can use things that we already know to answer this question. You know what the first thing I'm going to do is? What's the first thing I'm going to do? And what did they give me? 1 week. Because they want me to change weeks into seconds. What can I change weeks into? There is something that all of you have memorized because you've grown up. Days. So multiply. Where am I going to want weeks in the next fraction? On the top or on the bottom? So it cancels. I'll put days on the top. What's the conversion factor? How many days is how many weeks? 7 days is 1 week. Now if I stop there, that would be days. Gonna make it? Back here now. Does anybody know how many seconds in a day? I always ask. Someone might know.
36,000.
Nope. Nope. What can I break days into? Oh, do you all know how many hours in a day because you've grown up? Okay, let's go to that. So let's go. We'll put days on the bottom because I want it to cancel. hours on the top. Hours I can abbreviate with an H, I think. What's the conversion factor? How many hours is, oh, you said 24 hours is 1 day. And that'll cancel days. If we stopped here, we'd be in hours. Does anybody know how many seconds in an hour? Daniel. Okay, there is 3,600 seconds in 1 hour. If you didn't know that, you could go from hours to minutes. The H would go on the bottom, minutes would go on the top, 60. And then how many seconds in a minute? So you know both of those. We have an advantage in our class. Daniel happens to know that there's 3,600 seconds in 1 hour because it's 60 times 60, 60 minutes, 60 seconds. And since he came up with that, we'll take advantage of that. So I'm going to go like this then. I want hours to cancel, seconds, and you said 3,600? The 7 and the 24 and the 3,600, where are they? On the top or on the bottom? So am I going to multiply them or am I going to divide them? And I've answered the question that most kids have. Do I multiply or do I divide? Oh, do I need to do, I'm technically also supposed to go divide by 1, divide by 1, divide by 1. Will that change anything at all? So, cool, I'm going to ignore the ones. 7 times 24 times 3,600. How many seconds in a week? Slightly more than 1,000. You get 604, 800? Units? Seconds. A little more than 500,000 seconds. 600,000 seconds. Number 7. How many hours in a year? I'll ask in case anybody happens to have that memorized. Let's crunch it. Don't blurt it out. What I'm going to do first. Now, the correct abbreviation for years, look up, because of the stupid US system, a Y for years is technically incorrect because that's yards. The correct abbreviation for year is a lowercase a for annually. However, if you use the letter Y for year, I'm not going to take marks off because we don't live in the US and that's a stupid system that they have. But I'll do it correct because I'm a nerd. What can I change years into? What conversion factor do I know? Days? I would stay away from months because what would I go from months to? How many weeks in a month? It's not 4. And a bit. Right, Fritz? 4 and a bit. And how many days in a month? It depends. I wouldn't go to months. I would go straight from years to. What's the conversion factor? Technically 365 and a little less than a quarter, but we're not going to be that fussy. That's why you have to have leap years and things. Oh, can I go from days to hours? So, done, 2 lines. What's the conversion factor? How many hours is how many days? 24 hours is 1 day. Mr. Dueck, I figured out the pattern. We always multiply. No, I'm giving you fairly simple ones. We will be getting to some where there are numbers on the bottom. If they're on the bottom, you divide. 365 times 24. Now, I think Jack was just going to crunch that on his calculator without building a chain. And if you can get there, I'm fine with that. What I'm saying is this chain method will bail us out of far more difficult ones, and we're building our way up. Do you get 8,760? And that is hours. How many seconds in a year? Question? Hmm? I'd be fine with that. 8,760 would be 8.76 times 10 to the third, which is more writing than just writing out 8,760, and I'm naturally lazy. I'll usually pick the shorter way to write it. Usually. You know what I'm going to do first for number 8? Write down what they gave me, 1 year. What can I change years into? What? You mean I just figured out hours in the previous question, and if I was clever, I could go straight from years to hours and save myself a heck of a lot of time?
Yeah.
You're smarter than my morning class. My morning class, we went to days, then we went to hours. Oh. So we can go straight to hours. I happen to know that 8,760 hours is 1 year. Any of you seen the musical, the Broadway show Rent? There's a show in there, and there's a song in there, and the song in there, the chorus talks about how many minutes and how many hours there are in a year. And so I've had once or twice kids who happen to have seen that and happen to have memorized that catchy song, and they have a conversion factor that I've never bothered memorizing, but I think it would, if she knew how many minutes there were in a year, and she could pull that out of her back pocket. Okay, that's a nice time saver. I don't have that. What do we want to end up with? Seconds? Do we know how many seconds there are in an hour? We do. How many seconds in a year? More than 1 million or less than 1 million?
More.
Way more than 1 million or barely more than 1 million?
More.
Let's see.
No,
Oh, look at that. 31.5 million. I'm going to write, this is right, Kira, on the threshold of scientific notation-y. I'm going to go 31536 zeros. And units would be seconds. I was ignoring Ben. Ben has a question now. Yes?
What if I have 365 days, then 24 hours, then 60 minutes, then 60 seconds?
Same answer.
Yeah, same answer, right?
Yeah. That we were clever. We noticed that we'd done some of the work in question 7. That's a win. This chain method works really well when you don't know what you're doing. What? Here's what I mean. If you suddenly get a whole bunch of conversion factors and you don't know how they relate together, we can still bail ourselves out. How many centimeters in a mile? I don't know. Wait a minute. What am I going to do first? Write down what they gave me. The abbreviation for mile is MI. M would be meters. Abbreviation for minutes is MIN because MI is miles. Or you can write out the whole words, but I tend to abbreviate. Anybody here know how many centimeters there are in a mile? I should always ask. Okay, look at that chart of tables of weights and measures. Is there anything that we can use? A mile is what? Oh, let's do that. What a stupid system the US has. How many meters in a kilometer? 1,000. How many feet in a mile? 5,208. Oh, what a stupid system. How does that help? Is there anything that I can convert feet into? Not on the chart. But here now I'm gambling because you've grown up close to the US that you might have something else in your head that you can do with the US measurement feet and break it up into something else. How many inches in a foot? "12 inches in 1 foot. If we stopped now, we'd be in inches. We want to be in centimeters. Oh! What do you see? Look at the chart. Yeah, there is a conversion factor from inches to centimeters, yes? So this method here bails you out of a lot. You really don't have to somehow come up with esoteric facts and things. If you have them, fine. But just by building a careful fraction chain, I can hopscotch my way along and figure out, so inches, centimeters, and it's 2.54 centimeters is 1 inch. $5,280 times 12 times 2.54 divided by 1 divided by 1. I'm clearly going to skip those. You get 16934.4. and this is centimeters. I like question 10, I like question 10, I like question 10. Question 10 is a nice question. Why would I say that? I like question 10, I like question 10, I like question 10. Question 10 is a nice question. Why would I say that? Why would I say that? Boy, you're not my brightest group. Okay. You may see that question in the future sometime. You should tend to notice when a teacher emphasizes certain questions and pay attention, because that usually is a hint. What do I like about this question? It's a two-step conversion. What did they give me? I'm going to write down what they gave me, except never write slanty fractions. Slanty fractions are evil. Clearly show what's on the top and what's on the bottom. Write vertical fractions, because that way we know what's on the top, what's on the bottom. Dan, we're going to have to do two things. We're going to have to convert miles to kilometers, and we're going to have to convert hours to seconds. Which one you want to do first? I don't care. Pick. Okay, so in my next fraction, where am I going to put the miles? On the top or on the bottom? What can I do with miles? That would be clever. I could go feet, inches, but wait a minute. I have it in centimeters, and going from centimeters to meters is pretty easy. So let's use that conversion factor that we already calculated. I like that. Maybe you guys are my stronger group then. 160,934.4 is 1 mile. Because now I want to go from centimeters to meters. Where's the centimeters going to go? On the bottom. Meters is going to go on the top. Centi is what? Where's the 100 going to go? On the top or on the in front of where there isn't a centi? So you don't memorize top or bottom. You memorize that it goes in front of the base unit. I wrote 10 squared rather than 100. Now if I stopped here, that would be meters per hour. Now let's take care of hours. Where is hours right now originally? On the top or on the bottom? So where am I going to put it if I want it to cancel? Dan, do you by chance know how many seconds there are in 1 hour? So you're telling me 1 hour is 3,600 seconds. And you'll notice that 3,600, Matt, ended up on the bottom. Did. Which means I'm going to divide by that. I guess on my calculator, look up. If you've been following along, you can go 60 times answer button, because I happen to have the 160.93.4 stored on my, or 9934.4 stored on my calculator. It's worth finding where your answer button is. For some of you, it'll be right next to your equal sign. Some of you, it'll be second function equal sign. Some of you, it'll be second function right next to equal sign. And then times 10 squared divided by 3,600. Now, I have another trick up my sleeve because I'm a bit of a nerd. I know that going from miles per hour to meters per second is roughly half, but a bit smaller. The answer is going to be a little less than 30. This is a total guess. I bet you it's around 26 or 27. It's going to be 60 divided by 2 minus a little chunk. Is it 26 or 27-ish? Yeah? So I have a few other tricks up my sleeve if I don't have a calculator handy. Oh, I typed this wrong. What did I do here, Mr. Dueck?
The meters over centimeters, which we have 100 centimeters, and over below 1 meter.
Oh, it's 10 to the negative 2. You read the wrong conversion factor. You said 100. No, it's 10 to the negative 2. No, I said, what's the conversion factor for centi? Negative 2. Now you wrecked that. I can't use my answer button anymore. Never trust Dan again. Times 10 to the negative 2 divided by 3,600. Does that look better, Mr. Dueck? Yeah. I said it's going to be around 26 or 27, 26.8. What's on the board? Okay. I never, with you, I never have. I like number 11. I like number 11. I like number 11. Number 11 is a nice question. Why would I say that? Didn't you hear me say that? You're the kind of student that tends to notice when a teacher emphasizes certain things, and good. You'll be okay. And what do I mean by I like that? I like that. You'll notice we had to convert two things in number 10. We're having to convert two things in number 11. They want us to convert 4,356, what's capital T? Terameters per year. We want to convert that to kilometers per hour. How? Well, I need to convert terameters to kilometers, and I need to convert years to hours. Doesn't matter which one you do first, pick. Years to hours. Where is the A, the years, right now? On the. So where's going to go my conversion factor? On the. If I want it to cancel, where's going to go my conversion factor? On. Yeah. Do we have a conversion factor for years and hours kicking around somewhere? That would sure be convenient if we did. We do. What was that? 1 year is how many hours? Will. Thank you. If we stopped there, that would be terameters per hour. Now, we need to get rid of terameters. Terameters was on the top. Where's it going to go in my conversion factor? On the? Yes. And we replace tera with the actual power of 10, as is on your green sheet. So what's the prefix that tera can be replaced with? Tera is 10 to the what? 10 to the 9? Oh, 12? Okay. If I stop there, that would be meters per hour. I want kilometers per hour. Will, where is the M right now? On the? Where do I want it? My conversion factor. And I'm going to put kilometers on the top, but I'm going to replace the kilo, the K, with its metric 10 to the equivalent. Kilo is 10 to the what? It's going to go on the bottom this time. So I guess on my calculator I'm going to go 4356 times 10 to the 12th divided by 8,760 and also divided by 10 to the 3rd. What do you get? I have no idea what this one's going to be. Times 10 to the 12th divided by 8,760 and also divided by 10 to the 3rd. Do you get 497260274? Okay. I would love to write this in scientific notation, but I'm going to have to round off to do it. So, okay, I'm going to just arbitrarily go to about 3 sig figs. I'm going to go 4.97 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. 4.97 times 10 to the 8th. Units, kilometers per hour. By the way, that number is impossible because that number is faster than the speed of light. Oh, no, it's never mind. It's kilometers per hour. If it was meters per second, we'd be faster than the speed of light. But that might be doable. I take that back. Yes, some of you have figured it out. Turn the page. We're almost done. Can you wait a little bit longer? Because we have to let you dream. Number 11. In August of 2017, Mavis Wanchik won the largest ever U.S. Powerball lottery ticket. She won $758.7 million. Let's Oscar play around with some of these numbers. A. Suppose she spends $1,000 a day. Can she spend that in her lifetime? Let's find out. How? How many years will it take her to spend $1,000 a day? How can we calculate that? What are you going to type? Tell me. no need. I think what I'm going to do is this. I'm going to take that 758.7 million, and the first thing I'm going to do is I'm going to divide it by 1,000 so I can see how many how many days it's going to take. $1,000 a day, how many days go into that? I'm ignoring you, Ben. Million, I know, is 10 to the 6th, so I'm just going to do that. And I'm going to divide it by $1,000 per day. Can you do that on your calculator, please? That'll tell us how many days it's going to take her. I'm getting it's going to take her 758,700 days. 700 days. And now we're going to convert that to years. Do I have a conversion factor to go from days to years? What's the conversion factor, Abby? Oh, so you're telling me 365 days, and I know days goes on the bottom. I know I divide by 365 because I want days to cancel, is 1 year. So I'm going to take this number and divide by 365. How many years will it take her to spend that money if she spends $1,000 a day? She's not doing this in her lifetime, not even close. So let's spend faster. What if she spends $500 an hour? Okay? How can I figure that out? I think I'm going to use a similar strategy, Haley. I'm going to take the number that they gave me, 758.7 million. I'm going to divide it by 500 to see how many hours that is. And then I'll convert the hours to years. Can she spend this in her lifetime, I wonder? So, 758.7 million divided by 500, and I get 151,700. That's hours. Hey, I don't by chance have a conversion factor that relates hours and years, do I? What was it? And by the way, the fact that we have that gives us a shortcut. If not, I'd build a chain. But it was 8,000 something, yes? Sorry? Yeah, I got the 8,000. That's why I said 8,000 something, Captain Obvious. 8,760. And that's going to go next to hours because it's that many hours. Is 1 year. So I'm going to divide this by 8,760. Can she spend that in her lifetime? If she spends $500 per hour, 24/7, no eating, no sleeping, can she spend it all before she dies? How many years would it take? So can she spend that all before she dies? Not even close. Except she didn't actually win $758.7 million. Whenever you win a big prize, they always pay it out over 20 years, or you can take a smaller amount of money up front. And she chose to take the smaller amount of money up front. So she chose to take $480.5 million up front, which is only a smaller amount of money in comparison to the 780 million. It's still a crazy amount of money. What if she spent $10 a minute? Could she spend that? We're going to pick up with that on Tuesday.